Hi guys, today we're going to take a look at different sets of numbers. So looking at these signs that are written down, you can probably recall them from your memory somewhere. You've probably seen them on a math textbook or on math magazines or any sort of thing like that. So today we're going to talk about what these symbols mean. So the first one, we start with natural number. So natural number can be, when you see the symbol as this, so start with like a vertical line and an N after it, it means natural number. And what does natural number mean? So natural number is sometimes start with 0 and sometimes doesn't. So it's under different cases. So you have to ask your teacher or your math teacher, in our class, does 0 count as a natural number? So in our class, it does count. So I'll write it out. So from 0 to 1 to 2 to 3, blah, 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 and it ends. So this is what we call a natural number. So natural numbers are first, they're all whole numbers. So what does this mean? So this means that they cannot be decimals. So it can be 1.2, it can't be like 2.5. So those are decimals. They cannot be like natural number. It have to be like a whole number. That's first condition. So the second condition is that must be positive. So they must be positive. They cannot be negative number. Any negative number is not a natural number. So conclusion is that natural number are whole numbers. They're counting numbers, and they are all positive. They cannot be negative. So let's look at the next one. So the next symbol is kind of like a 2Z along each other. So what it does mean is that it means integers. So what does integer mean? So example will be -3, -2, -1, 0, 1, 2, 3, blah, 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 blah. So what are integers? So the first condition of integer is as the same as natural number, that it must be whole number. So numbers like 2.5, 3.6, they're not integers or natural numbers. They are, because they're decimal, so integer have to be a whole number. That's first condition. And the second condition, it can be negative or positive. So it can be negative and positive. So negatives, in this case, -3, -2, they're all integers, and they can also be 1, 2, 3. So they're whole numbers, but they can be positive and negative, right? So the only difference between integer and natural number is that integers includes all the negative number, maybe sometimes 0, depends on what your math teacher says. So the next one will be the rational number. And this rational number is simply like a Q with a 2 vertical dash in the middle. So what does rational number means? So rational number means that any number that can be written in the ratio of two integers. This might sound complicated, but it's actually not. So let's rational number are P divided by Q, where P and Q are integers. So what does this mean? So mean that rational number can be written, so any rational number can be written in the form of a number divided by another number, an integer divided by another integer. So for example, like 1/3, if it's decimal, we can write it in the form of 0.3333 blah 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 blah. It just continues, right? So the main difference between rational numbers and integer and natural numbers is that rational number can include decimals, just like in this case I just written. So this is a rational number. Why? Because it's 1/3, where 1 is an integer and 3 is also an integer. So the rational number can also be always be written in the form of an integer divided by integer. So would 2 be a rational number? Would 2 be a rational number? Yes, it would, because 2 can be written in a form of maybe 6 divided by 3, 6 and 3 are both integers, so 2 must be a rational number because it can be written in the form of a integer divided by an integer. So let's look at the next one. The next one we have real numbers. So a simple explanation of real number would be that it's the big guy that can handles everyone. So real number includes every rational number, every integer, and every natural number. So every number that you can ever think of, no matter how bizarre they are, how big they are, they're all part of a real number. So real number handles everyone. So real number is always every other numbers are always included in as part of real number. And there's some special case I want to talk about, which is irrational number. So that's irrational symbol can be written down as a vertical line and a p. So this is irrational number. So what does this mean? So you can kind of look at the definition of rational. Definition of rational number is integer divided by integer, and well, the definition of a irrational number, that can be quite obvious, right? The definition of an irrational number would be that it cannot be written in the form of a integer divided by integer. So what would be an example of an irrational number? Well, it will be pi, right? Pi is like 3.14 blah 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 blah. It cannot be written in the form of an integer divided by an integer, so it often cannot be written as a fraction. And that will be like an example of a irrational number. So remember, rational number is can be also always written in the form of an integer divided by an integer, and the irrational number cannot be written in the form of an integer of an integer or a fraction. So but irrational is also part of real number. So like what I said, real number is like the big guy that handles everyone. So any number, pi, e, or any number, any rational, any integer, any natural number, any irrational number, they're all part of real number. Real number is the set of number that includes everything, right? So that will be our introduction to different sets of number. They will be really useful later on, and it will be really useful throughout all your college mathematics, and they will be seen a lot more as you get more advanced, and you would dive more deep into the meaning of these. But this is calculative proof. We'll just discuss the basic definition of these.